Wait, I didn't get those. I just noted it.
Okay, I will bring those. Alright, based on these clues,
I got one.
okay, you need to figure out which line is this talking about. So it's not a vertical line, the y-intercept is greater than -3, the slope is less than 1, it's perpendicular to another line on the graph, so remember what that means, and is parallel to any line with a slope of 0. So I'll give you a few minutes to think about these clues and figure out which line this is. Which line do we think? Kabir.
For D, I said number 1.
You're saying line D.
Line D with the first one.
Okay, so it has to match all of these things.
Oh.
But
Oh,
yes,
never
it would
mind.
definitely match this. D is not a vertical line. Okay.
I thought it was.
Is
it F?
Why F?
Because it says it's parallel to any line that has a slope of 0.
So let's remember.
Oh wait, no wait.
Do the opposite. So slopes of 0 are horizontal. This would be vertical, so it could not be F because of this one / the last one. Why C? Okay. So it is perpendicular to this one, definitely. It is not vertical, correct? Is the y-intercept greater than -3? Yes, it is. Is that -2? Is greater than -3? Is the slope less than 1? Yes. So far, all of these are matching up. Is it parallel to any line that has a slope of 0? No. So had that last one not been there, C could have been the answer. But because of that last one, it's not C. Any others? I heard D. Why A? Okay, so it's not a vertical line. The y-intercept is greater than -3. The slope is less than 1. Is the slope less than 1? Yeah. No. The slope here would be up to over 1, so it would not pass that one, so it didn't be A. Alright, so we have E, D, and B left. We had a D, and that matched at least one of these. Okay.
The y-intercept is 2. The slope, this is 0.
Right, so it passes that one.
It's perpendicular to another line F, and it's parallel, which has to mean it's 0.
So D is that correct one. So if you were thinking B, that was correct. All the other ones would not work. All right, questions on that one? That was tying in a bunch of things we've learned. Slope, graphs, perpendicular and parallel lines, all of those things. Sure, okay. All right, so last class we talked about parallel perpendicular lines. What we're doing today has really nothing to do with what we talked about last class. It's completely own subject. But you need your calculator. So if you didn't grab that, now's your chance to go grab that. Go ahead and put your phones away. Those of you listening to music, I would probably pause it because you need to know how to do this. Alright, so phones off the desk, not in your laps, not in your hands. Melanie, Diego, Angelo.
This is the best song. This is the song with last one.
Alright, so I'm going to go through this step by step. Caden, turn away. If you get lost or miss a step, all of the steps I'm doing are on this front page. If you have this front page and don't have anything written on it, for the quiz you can use your notes anyway, but for the test, if there's nothing written on this page, you can use it. But if you don't have it, I won't have extras, so keep that in mind. So I'm going to talk through the steps first, and then we're going to actually do it. So we're going to go into STAT, and I'm going to show you where all these things are. STAT is going to be where you do a lot of your work. Then we're going to go into edit. We're going to put data into list 1 and list 2. After we've done that, we're going to go back into STAT. It's going to look like this. So you have what it should look like. We're going to go into calculate, linear regression. So if you're doing this now, you're going to get errors because there's nothing in there. And then once we have gotten that information, we're going to figure out how to get our line of best fit. That is our goal today. Find lines that best fit data. Alright, so go to the next. If you want to tear that off so you're not flipping back and forth, you can do that. You can close it. Okay. So you're going to be given a set of data. That could be as ordered pairs and a table. It depends. Right, for example 1, we have the time and hours students spent studying for a test, not you guys or any of my students, this is random data, and then their grade based on the hours spent studying. So you have to think about which of these is your independent, which is your dependent variable, which depends on the other. Would the time spent studying depend on the grade, or would the grade depend on the time spent studying? The grade would depend on the time spent studying. So anything that depends on something else, that's going to be your Y. And then anything that can stand alone on its own, usually something like time, years, stuff like that, that's going to be your X. Right? If you ever get confused about that, there is something up here. Okay, I thought I put that up here. It's not up there right now. It will be up there by next class. That will show the difference between independent and dependent. This will help us when we go to put stuff into the calculator, so we're not putting it into the wrong thing. So in your calculator, you're going to go into STAT. Actually, let's reset our calculator first, so that everyone's doing math on this all day. So hit second plus 712. Except that's not it, right? Second plus 712. Second plus 712. Reset. The buttons I press are also at the bottom, except I pressed something at the beginning. But second plus 712. Alright, then we're going to go into STAT. The STAT is right next to the arrows. This one right here, going to go into that. And then we're in the edit screen, we're going to go into edit by clicking 1 or enter. STAT, edit, 1 or enter. And then the list of data you have, you're going to put your X's, your independent variables, in L1, and your Y's in L2. You can do that a couple different ways. You can type in the number and hit enter, or you can type in the number and scroll down. Either or. Take a second and fill out your L1 and L2.
Oh, I didn't see it. Thank you.
Put these numbers in your calculator. You have them? Yeah. Go to. Okay. Enter. Okay. Let's backtrack. Hit stat again. Enter. 1. Okay. So here, make sure you're putting in all your numbers.
I'll give you like another minute to finish putting those in. Once you have, so this is the most important step. If you don't put things in right here, everything else is going to be wrong. So double check your numbers, double check that these end up at the same place, that your numbers are correct. Right, so that was step 1. Step 2, go back into stat, scroll to the right for calculate, and then you can either scroll down to number 4 or hit number 4. You want linear regression, so be mindful. There are 2 of them. You want the one that's ax plus b, similar to our mx plus b. You want that one, so number 4. You can either hit number 4 or scroll down and hit enter at 4. You should be on this screen. You are not on this screen. I'm doing it step by step, so anyone gets lost. Anyone else?
Wait, is this?
That's the screen I have. Yep. I haven't gone any farther.
So scroll to the right. And then number 4. You're on that one.
Okay. So then, this is part of the step 2. Scroll down to store regression equation. That's this one right here. And you want to hit alpha, which is green, trace, which is at the top. So alpha, trace. And then you're going to hit enter 3 times. So this menu should pop up when you hit alpha trace. Really, you're just choosing somewhere where this equation is going to be. And then enter 3 times. Yes. So you may have. So if you don't hit alpha, but you just hit trace, you're going to end up calculating, which is not what we want. So make sure you hit alpha trace. Your numbers should match mine. Anyone numbers not match mine, or anyone not get this? This is your line of best fit. So I'm going to show you what this looks like. You don't need to do this part. I'm just showing you what it looks like. So I'll go back through that if you actually want to see this. But these are all the points we put in. This is the line that we just found in our calculator. This is the line that best fits this data. It doesn't touch all the points, it doesn't go through all the points, but it surrounds this data the best. That's what we're trying to find, the line of best fit. So if you want to see what I just did, backtracking. I went into my y equals. At the top, it says plot 1, plot 2, plot 3. You have to go up and hit enter so that it's highlighted. And then you're going to graph it. But when you graph it like normal, it's not going to look like that. It's going to look like your graph is going to look something like this. But in order to get what I just did, you have to go into Zoom. And we're going to go into Zoom 9, Zoom stat, because we have stat points. And then yours should do that. Yours may be X's or points instead of squares. Same thing. Right? That is an optional step. You do not have to do that part. Moving forward. Right? I am going to go redo something just so we can go back to those numbers. Right? So when we write our line of best fit, you can write all the decimals. You don't have to write all the decimals. You need to write at least 3. So 6.012 x plus 53.61 round 6. So y equals, I'll just know what I just said, 6.012 x plus 53.6. 3 is great. More than that is amazing. Less than that, you should be doing at least 3. Yes. Oh, the repeating? No. You don't need to do that. So if you write this, that's fine. It wouldn't change your answer. So your line of best fit, I'm just looking for you have at least 3 decimal places. Right? What's nice about this unit is all of your work gets done on the calculator. Like you're going to show things, you're just going to write things down, but all of the work is done in the calculator. So I'm going to show you a couple different ways. Some of this will be after lunch. If we want to predict the grade given for a student who studied for 0 hours, we want our x value to be 0. There are multiple ways to do this. 1, we can put 0 in for x, but we want it with all of the decimals, not just the ones we wrote. So we're going to store it for x. This is step 3. So I'm going to type in 0, my input number. And then the STO button right above on is going to give you an arrow. And then this button right next to alpha, that will be your X button. And then enter. I may have showed this to you before, I don't know. It'll look like nothing happened. But then I'm going to go back and grab alpha trace, or go into alpha trace, and hit enter. That's where I store my equation, and enter once more. And it's going to give me an answer. Right? Anyone get lost on that process? Or need me to do it again? I can do it again. Right? So for the first part, type in whatever number you need. So we were looking at 0. STO right above on. And then the variable you want. So I'm going to use x, which is right next to alpha. And then enter. It'll look like nothing really happened. And then before, when we were doing step 2, we hit alpha trace. We're going to do that same thing. So alpha trace. And then you're going to hit enter once to get this. And then enter once more to get an answer. If you did not hit alpha trace in step 2, you will not be able to do this. Everything is connected. But what it just did was solve the problem, put 0 in for x with all the decimals, and this is your answer. Right, so we're going to write that down, and then we'll stop for right now. And you can round your answers to 2 decimal places, so 53.62. So we found the answer for this first one. If this were something other than like a grade, like we were looking for the grade they would get, we would want to put labels. Like for the last question, instead of grade, we're looking for hours, so the label will put hours. Alright, so let's find 6. We're going to do the exact same thing we just did. So your calculator should already be programmed. Tomorrow I help you with that one. So we're going to do this process again, but instead of 0, put in 6. So 6, STO, X, enter. And then alpha trace. Enter once to get the Y1, and then one more time to get the answer. And you will not get that answer. So you don't need to do the graph? You just need to do this part. So we're on the same thing that we're doing. But we're on the first one. So we did step 2. I'm sorry, we did step 3. But we just put in, because you already did this part, right? I'm sorry. Trace, yes. Enter 3 times. And then you're going to do this part. Put in 6. And then STO. X. Enter. And then, like we just did up there, hit alpha trace again. Enter. Anyone else not get that answer? So to find all of your Y values, you can use this method. Store in your value. Here we go. Store in your value for X, get your answer. So we can say this is 89.69. That would be the grade they would get for studying for 6 hours. Now, the last one is opposite, because now we're looking for how many hours would it take to get more than 100%, which is unrealistic. But there's a couple different ways we can go about doing that. I'm going to show you all of them. You choose which way makes the most sense to you. 1 is to go into the table. 2nd, graph. So all these numbers should populate if you did your step 2. If you didn't do step 2, you got to go back and do step 2 so that these numbers populate. If we want the grade to be more than 100%, we're looking at our Y value to see where is it more than 100. So if we want the whole number, we can just say 8, and that would work. If we want to be a tad bit more specific, we have to change these so that they're decimals. So on top of window, there's something that says table set. It's in blue. So we're going to hit 2nd window. The 2nd window should take you to this. Right now this is starting at 0, but I'm going to change this to 7. And instead of counting by 1, we want it to count by, let's say, a half. I'm going to change it to 0.5. So 7, change the second one to 0.5, and then I'm going to go back into the table. 2nd graph. So now I can see somewhere between 7.5 and 8 is going to be my actual answer. So again, we could still just say at 8. If we wanted to find like the exact 10th, we could keep going. So I'm going to do it again. Go back to 2nd window. I'm going to start this at 7.5 now and change this to 0.1. So change it to 7.5, change what you're counting by 0.1 and go back into the table. Second graph. Right. Now I can see a little bit more clearly at 7.8 hours. It would be over 100. And that would be like the closest I could get to that. So I could say 7.8 hours. That would be my answer. So when you go to that information, come right back. Right? Now the work you would show for this. For these, if you were showing work, you would just say that you stored x as 0. Sorry. Or stored 6 for x. Your music is too loud. Right? That would be the work you would need to show for that. That's it. For this one, if you said you looked in the table, that would be your work. I just need to see how you got these numbers, that you didn't pull them out of thin air. All right, here's the other way we could find this. Let me make sure that what I'm about to say is correct. I was thinking about something different. So, if you were looking for a x value when you're given a y value, the table is going to be your best bet. So you're either be looking at the table or you're going to be looking in storing values. One of those two. All right, we are going to do that process all again for other problems so that we get the hang of this. Practice. The only way to get better at something is to practice. But really quickly, we're going to talk about this. You may want to take a side note. Extrapolation is when you're talking about something outside of the data. So in our set of data, if I were to ask, is 0 extrapolation or interpolation? If I see 0, if 0 would fall inside of this data, that's interpolation. But if it falls outside of that data, it would be extrapolation. So I see this one starts at 1.5 and it goes to 7. Would 0 fall between those numbers? No, so that would be extrapolation. Right, 6 hours, would that fall between those numbers? Yes, so that would be interpolation. So really you just have to know what those mean and how you can look at data to see that. For the greater than 100%, that would be in your y's. So I see my lowest is at 70, my lowest is at 54, my highest is at 98. Does that fall within or outside of that data? Outside, so extrapolation. Right? So does it fall within the data or does it fall outside of the data? That's all that those words mean. Right? Questions so far? Okay. So now we're going to do example 2. Exactly how we just did the first example. When you start to put these in, when you go back into staff and you go back into edit, instead of hitting delete or clear right here, there's one thing. If you go up to the top and hit clear and then move away from it, it will clear out the whole list. If you hit delete, you're going to delete the whole list, including what's up top. It's going to mess up everything. So don't hit delete, hit clear. So at the top, hit clear and scroll down. Okay. Start to put in first. would the amount of fat determine the amount of calories, or would the amount of calories determine the amount of fat? Which one would depend on the other? Fat depends on calories, or calories depends on fat? Calories depend on fat, so the calories is going to be your y, the fat is going to be your x. So that's going to be L1, this is going to be L2. So start putting that data into L1 and L2. Be careful because it does say 560 twice. Alright, I'm going to give you 10 more seconds to finish putting in numbers if you haven't already. So now I'm going to do step 2. So remember that you can be looking at your instructions as I do this. So stat, scroll over to calculate. Number 4. Scroll down to store regression equation. Alpha trace. Hit enter 3 times. So I just did all of step 2, but I did it a little faster than what we did the first time. Anyone not get those numbers?
What's that? Go over to calculate. Number 4. And then scroll down to store regression equation. Alpha trace. And then enter 3 times.
Right. Anyone else not get those numbers? You put the numbers in.
Oh.
You remember that number?
I do it all the time. I think it's
So you're basically right this, right?
yeah, but
Alright, so we have our line of best fit. We're going to write that down. Y equals 14.439. X plus 133.934. Alright. For the next question, it asks to predict the total calories for our sandwich with 35 grams of total fat. So we have the fat, we have the X, we're looking for Y. So when we're looking for Y, we can do what we did before, store it in as X. So this is your step 3. 35, STO, X, enter, and then alpha trace, enter twice. So the total calories would be 639.28. Make sure you put your label of calories Anyone not get that answer? You still have you have the data, so we'll go back into that. You accept two. You have to do this part.
No sé por qué aquí de 35. No sé dónde se
Now you have the right equation, so you try to end, you should right? As a reminder, if you do not do step 2, all of it, you will not get the right answer. So you have to make sure we have the right equation, the right data, all the things. Anyone else not get that number? So for the second one, we have to predict the total grams of fat for a sandwich with 1,000 calories. So now it's opposite. So now we have a y and we're trying to find x. So this one we can go into the table. Oh, except we have to change our table back. So I'm going to go into second window. Everyone has to do this if they were changing this. Change this back to 0. And change this back to 1. Because if you don't do this, it's going to take you forever to get to 1,000. Okay. Then you can look at your table, second graph. Okay. I see that it's slowly going up. So then it kind of becomes a guessing game. Someone give me a number that they think it might be. It has to be more than 25. Sure, let's try that. So I'm going to go back into the window, second window. And I'm going to change the 15 to 60 and see what we get. Okay. 60 works. If you chose like 50, 50 wouldn't be high enough. And that would tell you you'd have to keep going. Keep scrolling until your y value is more than 1,000. So once it's more than 1,000, that's the number you can put. I just mixed two words anyway. So 60 total grams of fat for a sandwich. You can put grams, you can put grams of fat, either one. Okay. Does 35 fall within the data or outside of it? Outside, so extrapolation. Does 1,000 fall within or outside of the data? Outside. Most of these are going to be extrapolation. Very few times do you have something within the data. Because that's really the whole goal, to predict something outside of the data. Right? Do we have questions on how to find line of best fit and how to use it to predict so far? So I'm going to show you one more time how to do these, but with a different type of problem. So look at example 3. What's different about this problem is it now has years. So anytime we have years, the first thing we have to do is change the first year to 0. Every year after that is going to be how many years has it been since the original. So from 1986 to 87, how many years have passed? 1. From 86 to 88, how many years have passed? 2. 86 to 89. 3. 86 to 90. 86 to 91. 86 to 92, and 86 to 93. Now, sometimes you can assume that it's just going to go in order. Sometimes that is not the case. You have to be very careful. You can make a pass. Alright, so this will be the first step. Every single time you have years, change it to 0, and how many years has it been since the original? Once we have changed it, you're no longer using these. Cross them out so you don't. Yes. You would need to practice. Right. Now the calculator portion, that is the same. So we can go ahead and put these into our calculator. Wilbur, are you putting these in? Louise, are you putting these in?
The new one?
Yes, example 3.
Just add the one so you already did. That's what you're supposed to do. Let me see this. How do you erase it? Okay, so. Sounds like you know. Sounds like you know. Check on me. Be honest, dude.
Did you put these into your calculator already? Right. Some of you already started moving on to the second step. I'm going to do that up here, but if you need me to walk you through it again, I will do that. Stat, scroll over to calculate, number 4, go down to store, regression, equation, alpha trace. But that's not what I just did. Try again.
This is quick.
Enter 3 times.
Now you put the I have trouble with this. I said error. First click.
Edit, enter.
I should put error, bro.
Yeah, you just Did you find the equation?
Boom, I got it. Bro, what? That's the question. Wait, I think I got it wrong. I said error. Yeah.
Yeah, it's because you put in the years instead of 0, 1, 2, 3, 4, 5, 6, 7.
I already changed that thunder.
Yes. Go back and just add 1.
Wait, what is it? 0, 1.
At the bottom, so that so you get the last number.
And then do I have to do it again? Well, how do I get rid of it?
Delete.
Oh, I'm not trying to see that. No. That. Stop playing.
Minus
How did you do this?
this source. Yes. Isn't it 7x?
Sure.
7?
And the 8 is that what you said?
Wait.
4, 8.
Sorry, I'm confused as to what you're talking about. For right here?
Yeah. Isn't it supposed to be 4, 7?
So it's whatever this number is. So these are just how many years has it been since.
Oh, you rounded it up. Okay.
Oh, at the end. Yeah,
Yeah.
my bad. Yes.
I know.
3, 6, 5, 6, 9, 1, 7. Yes. Round the last one up. My bad. We were in a disconnect. I got it now. Okay. So to answer the next two questions, you have to know how many years has it been since the original. So from 1986 to 1998, how many years has that been?
12.
Yes. I like blank. So we're going to put in x equals 12 for that. If you're not sure, you can always subtract the years and store 12 as x. 12 STO x, enter. Alpha trace. Enter twice. I'm wrong. So that would be the number of cell phones in 1998. 33663. If we were talking number of cell phones, could we have a decimal of a cell phone? No, that wouldn't make sense. So we're just going to round up. Right. Anytime you have a real world problem where you can't put a decimal, so like the other ones, calories and fat can be decimals, grades can be decimals, amount of hours can be decimals, all of those are fine. But we can't cut a cell phone in half, so we have to round up. Even if it's not a round up number, so if it was like 0.2, 0.3, 0.4, we would still round up, because that's, maybe they were in the process of making it something. Okay. Right, how many years has it been since from 1986 to 2012? 23. So let's do the same thing. Store 23 for x. 23 STO x, enter. And then alpha trace, enter twice. So again, round up, so 67875. That was the wrong one. Last one, we want to look at the table. We want to see what year we'll have over 1 million cells. So we know in 2012, 23 years later, we're not at 1 million. So we're going to start at, someone pick a number higher than 23. What year do we think? How many years has it been since?
300.
Sure. That might be too many, but it might be, who knows? I'm going to go into the table, second window, change this to 300, and see what happens. Not quite. But we're close. 323 years later. So then we just gotta figure out what year that would be.
2312.
Yes.
I guess the 23 years is long.
Say that one more time.
That, I guess it's wrong.
What number should I have been?
26.
Okay. So I just went off of whatever you guys said. I could have actually did the math too. But yes, I should have been 26. I'm going to redo that problem so I can redo that math. 26. 0, 11. Okay, so 77,205 should have been an entrance test. Thank you for catching that. Right? Do we have questions on any of this so far? Would 1998, 2012, and 1 million, would these be extrapolation or interpolation? Extrapolation for all of them? Yes. 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 So, in a moment, I'm going to let you practice, but I want you to look at the very last page. The one that looks like this. Yes. After, yep. This is the only one that's different where you don't need your calculator in order to do this. This ties into the graphing that we were doing before. So Jacob's next. Yes, you. You're going to be at the over. So for this one, we're trying to find which of these equations would best fit this. You could graph them. So that would be the easiest. So if I start to graph this point, I have a y-intercept at 1. My slope is 2, so I'm going up 2, right 1. Already I can tell that this is not going to be it. This line that I just drew does not go through those points. So it's not going to be a positive anything. So we can get rid of A and B. Between C and D, which one do we think would be the answer? Okay, good guess. C. Okay. I'm going to graph that one. Even though it doesn't go through every single point, it's surrounded by those vectors. So C would be your answer. So when you get a question like that, graph it, see if the points match or not. Okay? So you do have a delta map on this, but this one is not due until the 27th. You have one due today on parallel multiplication lines. You have practice in this. You can go through any of this, work on delta map. Use each other. Use me if you have questions. Use the rest of this time for practice.